your screen. All right, now it's being recorded. So these are the notes that you're going to need for today, or from today, and this information will be online, and it will be on the test. So when we look at our periodic table in class, and not all of you are in the classroom, but I have a big periodic table on my wall, and it has some color coding. And actually, let me stop sharing for a second so I can show you. See it? See it right there? See that big guy? So that's a big periodic table that I have in my classroom. And it has color coding. Now, if you were to look at a different periodic table, if you were to Google one online, the color coding might be different, and that is totally okay. But all periodic tables color code to tell you the different states of matter. And so on my periodic table, I have white, I have black, I have red, and I have blue. And I know I've talked about white already. Does anyone remember what the white is for? Why would some of them have their symbol written in white? Like Mason? They're not found in nature, they're man-made, okay? And so those are ones that are unstable. And so they maybe were found in nature at one point or were found on Earth. Some of them last only a couple thousand years, some maybe a couple hundred, some a couple years, some of them a couple minutes. We even have elements that last 1/100th of a second before they break apart. They are just extremely unstable. So all these white ones are ones that we have made. They might have existed at some point, but they don't exist naturally anymore. So we call them man-made, okay? I also have only 2 elements on the entire periodic table that are blue. Anyone guess what state of matter blue would stand for? Think like the natural option here. No?
Liquids?
Liquids, exactly. So the 2 blue elements, bromine and mercury, are the 2 elements that are liquid at room temperature. Everything can be solid, liquid, or gas in the right conditions, but these are the conditions at what we call room temperature. We also have some red elements, and I'm going to just point some of them out before I ask you to guess. We've got like hydrogen and helium and oxygen, neon, argon, krypton, xenon, radon. What do those all have in common? They're all gases, okay? And then the rest of the periodic table is solid. So actually the first thing I want to do, let me share my screen and show you, because we're all going to do this, is I want us to label our yellow periodic table so that you have it there. So what I decided to do, oh wait, I'm not sharing that yet, am I? Can you guys see it at home?
We can see it.
Oh, okay, perfect. Didn't have a green box around it. All right. So I've made like a little key here because we're going to color code later. But I did a little water droplet for liquids. I want everyone to write this on their yellow periodic table. Put a little water droplet for liquid. We decided in first period to use a box to show like a solid shape. We drew a cloud for gas. And we drew a stick figure for elements that are man-made. That way we can label on our periodic table. And if you're home because you're remote only, or you're home on a day that your group is home, or you're home because you're quarantined, you've still got the color coding essentially, because we're going to do it with symbols. So the first thing I want to do, thanks for answering, Caitlin, you were correct. The first thing I want to do is I want to label the liquids. And so mercury, which is element number 80, you give it a little water droplet or liquid droplet, because mercury is a liquid. And then our other liquid is bromine, element 35. So those are the only 2 elements that are liquid at room temperature. So element 80 gets a little drop, and bromine, element 35, gets one. Next, let's label our gases. And so remember, for gases, we are going to do a cloud. So let's start with the only gas on this side of the periodic table, that's hydrogen. And put a little cloud next to hydrogen. I'm just doing it next to the symbol. And then, so element number 1 gets a cloud. Element number 2 gets a cloud. Element number 7 gets a cloud. Number 8 gets a cloud. 9 gets a cloud. 10 gets a cloud. 17 does. and 18 gets a cloud. And then we're going to just go down these gases, the noble gases. So krypton gets a cloud, 36 does, 54 does, and 86 does. So I'm going to repeat that as you're doing it. You can do a quick check. The ones that get clouds, the ones that are gases at room temperature, are element number 1, number 2, number 7, number 8, number 9, 10, 17, 18, 36, 54, and 86. Everybody good with the gases? Awesome. So now let's do the not found in nature, the man-made ones. So remember, we're doing little stick figures. And we need to do a stick figure next to number 43, which is kind of random. I don't know exactly why that one's unstable. We got element 43. Element 61, which is down here in the bottom section, a little bit hard to find. So my finger's pointing to it. Element 61 also gets a stick figure. And then 93 and up. Every element 93 and higher gets a stick figure. So I'm going to do 93, 94, 95, 96, 97, 98, 99, 100, 101, 102. And I have to go back up here to get to 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, and 118. So again, it was elements 43, 61, and then 93 all the way to 118. So we've done the solids. No, I'm sorry. We've done everything but solids. We've done the liquids, the gases, the not found in nature. Every other element is a solid. So if you want to go and put a square on every other element, you can. I'm not going to say all those numbers because it's a lot. But everything else in the periodic table is a solid. If you look at the one on the wall up here, all those symbols that are in black is definitely the majority of them. So those ones are all solid at room temperature. The other thing we're going to take notes on today is 3 categories that we can separate everything in the periodic table into these 3 categories. And everything on the periodic table is either a metal, a non-metal, or a metalloid, sometimes called a semi-metal. It's up to you if you want to write it on the back of your periodic table or on paper somewhere. But again, this stuff that I'm addressing right now is going to be this is the last information you need for the test we're going to take the week after spring break, but this stuff will be tested on. So I'm glad you're sticking it out on the last day. Anyone have an idea about what characteristics I might use that we could apply to all metals? What do you know about metal? There's a lot of metal in our world. It's usually solid, but I'm not going to write that one down because there's one exception. What's the exception? It's mercury.
Mercury.
Yeah, good job. How would you describe a metal besides solid? I know I'm kind of being vague here. Yeah, a lot of them are pretty heavy. I don't know if Yes, that is an excellent one. So all metals are good conductors of heat and electricity. We wouldn't have electrical wires without metal, and we cook our food on pots and pans that are typically made of metal. Now we sometimes use stoneware stuff, which I don't think is metal, but typically they've been metal. So metals are good conductors of both heat and electricity. That is a true statement. Sometimes I walk outside in the parking lot when the sun is shining and I wish I had my sunglasses. What's that metal doing? Reflecting in my face because metal is shiny. No, I put my sunglasses on to protect myself from the shiny metal out there. I don't know. I was trying to lead. I'm late. It's Friday before break. So metals are good conductors. Metals are also shiny. Or sometimes you'll see the word that they're lustrous or that they have luster, which means that they reflect, so that they're shiny. We're going to talk about why next unit. This is a word you may not have heard of before. Metals are malleable. Anyone heard of that one before? What does it mean, Cooper?
You can like mold them.
Yeah, you can mold them. So like you pound it and it holds a shape, or you get your brand new car and someone's shopping cart bumps into it and now there's a ding or a dent that stays there. It's not, no, because welding's like melting them together. That's a different sort of process. But I guess, yes, metals can be welded. But malleable basically means you can pound it and it holds its shape. You could crush a soda can and it stays crushed. It doesn't bounce back. And you might be thinking, of course it doesn't. But my son yesterday is 6, and he was playing in our laundry basket, and then he flipped it upside down and he was sitting on the laundry basket and he dented it with his weight. And he like hopped off because it scared him and it popped right back. And he went, oh, cool, I didn't break it, because he thought he had broken it. And then he did it like 5 more times. And I was like, eventually it is going to crack and break. But he thought it was so cool that he could sit on this plastic, it dented, and then when he got off of it, it popped back. If he had had a metal box or something and he sat on it and it dented, when he got off, it wouldn't have popped back. That is a characteristic of metals, and it's called malleability. The fact that it holds that shape. Our last word for today is that metals are ductile. Cooper, Charlotte, do you know what that one is? Or anyone else? So ductile means it can be drawn into a wire. That you can take metals and you can stretch them into these long, thin pieces and they stay connected. And the vocabulary word for that is ductile. And again, that's important for us, right? We wouldn't have electricity if metals were not both ductile and good conductors, right? They have to be made into those wires and then they have to conduct that electricity. So metals are all of these things. They're good conductors, they're shiny, they're malleable, they're ductile. Do you know what nonmetals are? They are not good conductors. They are not shiny. They are not malleable. And they are not ductile. A lot of our nonmetals actually end up being gases. So it makes sense that a gas isn't going to be shiny, or it isn't going to, well, it could conduct like this. It isn't going to be malleable for sure, and you can't take a gas and make it into a wire. So it makes sense that nonmetals are not that. For our few nonmetals that are solid, they're very brittle and powdery, and they would break if you hit them, not bend or kind of change shape. And then our last category is a metalloid, also called a semi-metal. And I'm going to be really not scientific here. I'm going to say they're kind of good conductors. They're sort of shiny. They're kind of malleable. And they're sort of ductile, which I realize this is really bad English. But that's basically it. Metals are these things. Nonmetals are not, and metalloids are kind of in the middle. They're not quite one, they're not quite the other. Some metalloids might be more shiny than others. Others might be better conductors than others. But they're not as good as metals, but they're better than nonmetals. Yeah, might be is a good way of putting it. They might be those things, but not guaranteed. So if you've been in my classroom, or if you can see my periodic table over there in my screen, there's an orange stair step on the periodic table. That orange stair step divides the metals from the nonmetals. That's why it's there. And if you look at your yellow periodic table, there's a bold line stair step. Again, that divides the metals from the nonmetals and the metalloids. And so what I wanted to do with the three colors, if you have three colors, use them. If not, you can pick like three shapes, like a triangle or a heart or a star, just shapes that you can draw quickly. But I want you to make a little key. I'm going to use red for metals. And I'm going to use blue for nonmetals. I'm going to use black for metalloids, but again, you use the colors you have. Or you can just use a pencil and you can draw different shapes for each one. All right. We're going to start with the metalloids because those ones are the easiest to find because they are the ones that touch this stair step line. Now, hold on. They have to touch the stair step line with a side, bottom, or top. And it's every element that touches except for one. Which one is our exception? Take a look at those elements touching the line. Is there any element there that you're like, I'm pretty sure that's a metal? Riley?
No.
No, not that one. Aluminum. You've all seen an aluminum can, right? Is that a conductor of heat and temperature and bendable and all those things? Aluminum is a metal. It's not a semi-metal. But the rest of these are. So I'm going to say the number, and I'm going to draw the little picture, or my little picture on the right of the symbol this time. And I'm just going to draw black dots here. But element number 5 is a metalloid. Element number 14 is a metalloid. Hopefully you're coloring along with me here. Element number 32 is a metalloid. 33 is a metalloid. 51, 52, 84, 85, 117, and 118. So it's how many elements is that? 2, 4, 6. 10 elements. I'll repeat it one more time. It's elements 5, 14, 32, 33, 51, 52, 84, 85, 117, 118. Hello. Now let's do the nonmetals because that's the next smallest group. So our nonmetals are element number 1, hydrogen gas, because you can't be malleable and ductile and stuff if you're a gas. So hydrogen is a nonmetal. Element number 2, helium is a nonmetal. Keegan, I videotaped this lesson, so you can watch it later because you missed almost all of it. And then everything over here, everything to the right of the metalloids is a nonmetal. Do you see where I'm pointing? So all of these elements that haven't been labeled yet are nonmetals. So I'm going to label element 6, 7, 8, 9, 10, 15, 16, 17, 18, 34, 35, 36, 37, 53, I can't count. I'm counting too much. 54 and 86. So I'm going to repeat those nonmetals one more time. It's element 1, 2, 6, 7, 8, 9, 10, 15, 16, 17, 18, 34, 35, 36, 53, 54, and 86. The rest of the periodic table is metals. So all of this section right here, all of this section right here, underneath the stair step over here, this whole section down here, it's all metals. Here's my cheat sheet, all that red. Okay, so the rest of the periodic table is metals. The periodic table is mostly solids and it's mostly metal.
Wait, so the first one we did was metalloids?
Yeah, the stair step was metalloids. To the right of
Dang.
the stair step and hydrogen was non-metals. And then this whole
Darn.
thing was metals. If you need to, you can just change your key. If you mislabeled something. So on the test that we're going to take the week after spring break, there's going to be questions that say something like, which of the following elements is malleable and shiny? And so you'll think to yourself, oh, they're asking me which one is a metal. And then you're going to go look at your periodic table and say whichever one on their list is red, if you use red like me, okay? So you need to know the characteristics of a metal, non-metal, metalloid, and you need to be able to identify metals, non-metals, and metalloids. You also need to be able to know the state of matter. So we labeled that as well. So that is it for my notes for today. So I'm going to see if I can figure out how